Question 2, we've got a question about this sequence of numbers, 3, 4, 7, 12, 19, 28. And we're asked to prove that these weren't randomly generated. Given that sequences are part of the syllabus, let's have a look at these numbers and just see if they form some sort of sequence that we could recognise. The best way to do that is to have a look at the differences. 3 up to 4 gives a difference of 1. 4 to 7, 3, 5. I'm getting very suspicious. That's 7, and this must be 9. Yes, it is. And I think you can see that the common difference we've now got is 2. So this is a quadratic sequence. But let's just go on very slightly and look at the second common difference, which I think you can see is 2 every time. And I think that would be enough proof to get full marks. But just for interest's sake, let's just go on and find out what quadratic sequence this actually is. So there are the numbers again. So given that we've now got a second common difference of 2, our sequence must be based on n squared, half the coefficient of this number 2. What does n squared actually give us? N is equal to 1, n squared, 1. 4, 3 goes up to 9, 4 goes up to 16, 5 goes up to 25, and 6 goes up to 36. And to discover the rest of the sequence, we have to take these numbers, 1, 4, 9, 16, and so on, away from the original sequence. This removes the quadratic element, which is n squared, and leaves us with a linear sequence. And we've got a common difference of -2. So our linear sequence must have -2n in its equation. Now we've got to test it. So we've got n squared minus 2n, and now we sub n is equal to 1. We should get the answer of 3. But in fact, we get 1, take away 2, we get the answer of -1. And the difference between -1 and 3 is 4. So we're wrong by 4. So our quadratic sequence is n squared minus 2n plus 4. I suppose we should try it for, let's say, n is equal to 2. 2. We get 4 minus 4, they go, and we should get an answer of 4. Yes, we do. So I'm happy that that is the answer. And yet again, I think this stage here is a perfectly good proof that the numbers were not picked at random.